All right, so part two, sinusoidal function transformations. That's such a hard word for me to get out, especially with my nose stuffy. Is what's called a phase shift. Okay, so do you guys remember how with regular transformations we can have the function translate left or right? Correct? Yes. Okay, that's called a phase shift when you're talking about trig functions. Okay, depending on the phase shift, you can either be looking at a sine function, a positive sine function, a negative sine function, or you could be looking at a positive cosine function or a negative cosine function. It just depends on your phase shift, okay? Now, remember, x's are liars. So if it looks like a plus, it's actually a minus. If it looks like a minus, it's actually a plus, because that rule has never changed as we've learned about transformations, correct? Okay, again, that's called our what? Phase shift. So instead of saying horizontal translation, we call it a phase shift, but ultimately it's just your horizontal translation. Okay, so let's talk about how to find it. So, for example, here we have a graph G, and when we look at graph G, we are trying to figure out which graph best fits what we're analyzing. So first, to start with process of elimination, is you want to determine, are you analyzing a positive or a negative function? Okay, that's one thing. And then thing number two is finding your midline. That's going to be your key. And if there is a period change, finding the period as well. But as you look right here, all of them have a B value of 1. Do we see that? Everybody has a B value of 1, so there's no change there. Your midline for each one is at, no matter what, the midline is at -1. So this is what I was telling you, August, why we couldn't say that it's always the y-intercept. So this is an example of why, because depending on where the function is shifted to, okay? So here we are. So when I begin analyzing this, remember I told you that it can either be a positive, negative. It just depends on what part of the phase you're analyzing. Does that make sense? All right, so up first, we have cosine x minus 1. So this would be if I had a positive cosine function, and that positive cosine function would be starting up here, and then going down, and then coming back up and ending at our values. However, does my cosine start off positive? No, my cosine function doesn't start off positive here. It could start off positive here, but because there's no phase shift, that means that I would be looking at the origin and analyzing. And because it's not shifted, and at the origin, I'm not starting off as a positive, that's why I can eliminate that one.
I'm not seeing.
Not see?
But wait, hold on.
Oh, I understand.
Okay. Depending on where we start. A cost would be a cup. So now we're going to look at -3. So -3 is now saying that you shifted your function to be at pi. Does that make sense? So now you're starting the pattern at, this is your starting. So if I go to pi, does it start off as a positive cosine? Yes, but what did it say it would start off as here? Negative. So is this the possible one for here? No, it did not start off as a positive. So now this is saying at pi over 2. So plus pi over 2 means that it's actually starting at a negative. Can I even see negative pi over 2 right now? I cannot see negative pi over 2. So then that means I have to do a little bit more work. Guess what I'm not going to do? I'm not going to do that little bit more work. I'm going to go back. I'm going to try the next one and see if I can do a little less work. So starting here, so instead of starting at 0, you're now starting at 3 pi over 2. If I go to 3 pi over 2, I start here, and what can I create? So I'm following the cycle, and what did I create? Is it a positive or a negative sign? Negative. So does this satisfy this rule? Yes. Okay. Your phase shift is now where you're analyzing the pattern starting from. Does that make sense? That's going to be the most simple way to think about it. So this one had me starting at the origin because I had not shifted left or right. And when I go to the origin, my sine function is not positive. My sine function is negative. So if I was to analyze it from here, this would have had to be -3 cosine x minus 1. And is this a -3? No. Okay. That's why when I was telling you guys that there are multiple ways to analyze a sinusoidal function, it depends on where you're starting at analyzing it. What interval are you beginning? Okay. Here, this time it said to start at pi. So when I go to pi and I'm analyzing a cosine function, I'm looking for the cup. This one started off as a positive. What did this function say it was going to be? Negative, and it's not a negative. So that's why that is eliminated. Yes. Okay. This one is start at pi over 2. Well, I can't see pi over 2, but in theory, what's going to happen? If I'm here on this side, on the other side is going to also be at the same, right? So in theory, pi over 2 would also be on the midline right here. Yes.
So,
Which means it would have to be negative.
so what, so how did, on the last question, how did you define, and this one is negative 2?
Good job.
I still understand. Because if you subtract negative 4 from 2, it's 2. So where did the amp to be come from?
Your amp is first you find your midline, right? So your midline is the average between your max and your min. So my midline, that's an ugly I'm sorry, equals 2 plus negative 4 divided by 2. That's my midline. And that's why our midline is at negative 1. Your amplitude is how far is your max from your midline. So you either can do it mathematically or you can literally count 1, 2, 3. So my amp is 3. Okay.
That makes sense.
All right. Now let's go the other way. So here we have all 4 variables. We have our A, we have our B, we have our C, and we have our D. Notice your B value when there's a phase shift is outside of parentheses, right? If it's not, then you have to factor it out, okay? In order to find your real phase shift. So what I want y'all to think about is looking at these, which cosine or sine function best models, well, what we have here. It could be cosine depending on where the phase is. So answering that, if you look at pi over 4, so pi over 4 is right here somewhere. Yeah. So analyzing pi over 4, where would it be? It would make it, how would it make it a cup? It would be right here at 1, right? So it would make it a sine. So if I chose this one, it would make sense for me to be at pi over 4. Does that make sense? So it couldn't be that one because of that. If I started at pi, pi could be a cosine, but it wouldn't be a positive cosine. It would be a negative cosine. And this has it as a positive cosine. Because they're all the same, you don't have to worry about checking the values of A, B, C, and D. You're just following these values, yeah. Because everything else is the same, right? The only thing that's changing for each one of these is its phase shift, okay? So here I'm at pi over 4. If I go back to pi over 4, it's at 1. And does it create a positive sine function? Yes, it does. So then it would be here. Versus if I go to pi, pi does not create a positive sine function. Pi created a what? A negative cosine function, right? So therefore, that's why it's not D. It would have to be C. Again, trig functions are just about analyzing pattern. Once you realize what the pattern is, then there's actually not a lot of calculations or math to it. Does that make sense? Because if you think about it, to find the amp and the midline, all we've been doing is adding and dividing by 2, correct? And then subtracting. All right. Ask some questions.
Right. Up at the point, stop when you start repeating. So
you want to identify your midline. Your midline is going to help you determine where you stop. Yes.
The midline is 1/2 or no?
The midline is at 1. Okay, again, what's 3 plus -1? 2, and then 2 divided by 2 is 1. So your midline is at y equals 1. And we also know that because it gave us our d value. Your b is your horizontal dilation. So it's what increases or decreases your period. Your b isn't affected. That's why it's factored out. Yeah. So as long as your b is factored out, it doesn't impact your c. If it's not factored out, then you would have to factor it out so that you could see what your real c value is. Okay? I will go back at the end. Let me, because we're running out of time. All right. So do you see how it really wasn't a lot? I mean, I love the question. So please ask me any other questions for clarification. And we only have one problem left. Yeah, I know, but I want to make sure we're good. Okay, the last one's going to be the most. So the example 8, we have our tried and true FRQ problem here. However, this time you're giving your F, your G, your J, your K, and your P, and it wants you to analyze it as a sine function. Okay, analyze it as a sine function and tell me what would be my A, my B, my C, and my D to satisfy these points. Okay, so first we're going to go ahead and identify our values. So based on what we have here, we know that we have a max of 16, midline at 11, and a minimum of 6. Do we agree with that? So we know that these values are 16, 11, and 6. That's what we're going to figure out. All right. So with that being said, F is at 2, G is at 5, J is at 8, K is at 11, and P is at 12. And we need to find our A, our B, our C, and our D. And we're analyzing a sine function. Where did I put it at? Oh, 14. Yes. Sorry. So our A equals what? 5. Perfect. What's our D? A and D are going to always be your easiest. What's our D? 11, because D is always your midline. B depends on our period. And what is our period? Our period equals 12, which equals 2 pi divided by B. So therefore, what would B have to be? It would have to be, I said it's 1. Who said it? 6. In the denominator, but what's our numerator? Pi over 6. There we go. So therefore, B equals pi over 6.
That's a 12 or what? 1 and 2.
Huh?
That's a 12 or 1 and 2.
Does it say 12 or 1 and 2?
12.
12. This, cross multiply. 12b equals 2 pi. Divide by 12. So b equals pi over. That's what we're about to figure out. So what is our C? All right. So we know that our B is pi over 6. Now we have to figure out our C. So if we're given these points, we're going to determine whether we are positive sign or A. So what we can see here, do you guys see that there's a negative sign? Yeah. We see that we can go back and have a positive sign. So if I was to do that, what would be this point right here? Yeah, well, like I could go back. What parts could I start off with pi over 6, like to make a positive sign function? I'm trying to make a positive sign. So what would this value have to be in order for this to be a positive sign function? It would be what? It would have to be a -1 because how far apart are each one of these intervals?
3.
3. Yes. 3, 3, 3, 3. Yes, no, maybe so.
Yes.
So this would be at -1. So therefore our C value would have to equal a +1 because X's are liars. So now we have our A, we have our D, we have our C, we have our B. Can I write the function? So my function would be h of t equals, and my A is 5 sine, B is pi over 6, parentheses, t plus 1. And then plus 11. That's option 1. You also have another option. Your second option would be if you chose to be at 11 and you followed it, would it still make a positive sign? Does that make sense? So it depends on, or it could be t minus 11 because you're starting at 11. They will accept both. No, G would make me a negative sign. If I was trying to say a positive sign, it would need to be 11.
Right.
Okay.
Okay, back to-
Yes.